Hey guys, so in this lecture we're going to be starting off with our first project, which is fully connected networks, and in that we're going to start with part 1, which is pre-processing the data. So let's get started. So as I mentioned, the first part of the project is to pre-process the data set. So before we pre-process the data set, the first thing to check is this and see if the GPU is connected or available. So we'll go to change runtime type and change it to GPU, and if it's GPU, leave it be and hit save or cancel. So our GPU is connected here. So in case it isn't in yours, then you click on connect and start your session. Alright, so my setup is done, so let's begin. So the very first step in this will be to import the libraries that we'll be making use of in our session. Alright. In the next line, we'll write from TensorFlow.keras.dataset and we'll import mnist set. So import mnist. Now once this is done, we will run this code so that our dataset is imported. So the first step was to import our dataset, which was mnist, and now we will also import some supporting libraries. So as you can see over here, the first step I'm doing is I'm importing NumPy, followed by which I'm importing the matplot library .pyplot as PLT, which is for visualization. Besides these two, we've also imported random. So these three libraries we've imported. So once this is done, up here one more thing we needed to import. So basically what we are missing over here is that we needed to import one more module, or basically one more function, which will be two categorical. And that will import from tensorflow.keras.utils and import to categorical. So what this does is it helps us process our labels. So that is the function of to categorical. Alright, so these are some of the libraries that we had imported. Now we need to fetch our dataset. So let me just write the code down now. So x underscore train, then y underscore train, then we'll write x underscore test, and now y underscore test, and this will be equal to mnist dot load underscore data. Now once this is done, we'll now execute or run this code. Alright, so our execution is done. So let's have a look at what we've done until now. So the very first thing we did is we imported our data set, and after importing the libraries, we used mnist dot load underscore data, in which we get split as well as processed data. And the data in this data set is already split into xtrain, ytrain, xtest and ytest. So basically the training and test data are separate already. Alright. So split data as well as processed data, both of them have been provided to us already in this data set. So now that we've done this, let's first explore our data set. So basically we'll check the data set now. So that will kind of help us understand what is this data set and how it is. And it'll also be good for us to understand what we're working with. So let me just write down a print function and have it executed. So basically what I'm trying to achieve here is I'm trying to plot the shape of all the data sets available inside. So basically I'm going to be writing individual commands for the xtrain, ytrain, xtest as well as the ytest to show you what the final shape of our data set is within this. This will also help you understand the size of our data set. So almost done. Just give me a bit. Alright. Final bits, and then we'll be executing this part as well. So as you can see over here, it's showing us the shape for our data set, and in this we have xtrain, ytrain, xtest, ytest, and they're both split into training and test. Your training has 60,000 samples of 28 by 28 sizes, and that was for x. And similarly, if you see, ytrain also has 60,000 samples of data, and similarly our xtest has 10,000 samples of data of 28 by 28, and ytest has 10,000 samples of data in it. So what this means is y has 60,000 labels in it, and these are single digit integer formats. And that is why in the y train we have only a shape of 1. That is because it's one dimensional. Similarly, y test also gives us 10,000 labels, and that too is in one dimensional format. So in order to understand this better, let's first plot the images. Let me just write down my code, and yeah, just give me a bit. Alright, so that took a while. So what we're doing here is we are making use of the matplot library in order to print our data set. So this is quite a popular technique that is used, and this is also known as the exploratory data analysis method, in which we first explore the data and try to see what it's like, what are the features of that data. So basically what we do is we explore the properties of the data visually. Alright, so I'm almost done with the code, just bear with me for a little while longer. Alright, so almost all the plottings are done. So we've added IAmShow, we've added title, we've added xticks as well as a subplot. Alright, so here our code is finally ready, in which we've given it a range of 0 to 6. So we basically want 6 images, that means from 0 to 5, and those images we want to visualize. So that is where this IAmShow function comes into play. That IAmShow will basically plot the image for us. Alright, so now that that's done, let's execute this and see what happens. And here we are. So this is the kind of output we have received right now from plotting this. So our first 6 images are these, which are numbers like 504, 192 in handwritten formats. So what we just did is we visually inspected the data right now, which helped us understand what type of handwritten digits we have in our data set. Alright, so 504, 192, we got these as our first 6 samples of the data set. So that was an overview of our data set. Now let's move on. So we got an idea of what the samples are in our data set, but now it's time to explore a single sample. So what we're going to try and see is how we can make use of that one particular single sample in a little more detail. So let me just, as usual, take the time out to write this code. But in this, basically I've defined a parameter num is equal to 0, using which I can change my sample as well. Alright, so print label y underscore train with num. So basically we'll be printing a table as well as the image. Alright, let me just write this code down so I can explain it to you better while focusing on teaching you rather than writing the code. So as you can see over here, I've also added a divider. Then digit equals to xtrain num. Then I'll print the num variable digit. Alright, so I think I'm done. Okay, yeah, so that's it. Now we will run this code and let's see what happens with this. Alright, so Control Shift and enter. Alright, so our execution is completed. So the single digit that we have appears something like this over here. So if you observe a little carefully, you will notice the values of our pixels, and that are in a different shape. So as we can see, our label is 5, and this is the shape that we are seeing for 5. So we're basically seeing the values of the shape for 5. So if we confirm with the figure above, we have somewhat a value like this that is being shown, a shape like this that is being shown. So wherever you're seeing a pixel value more than 0, the digit's value is being shown over there. So let's have a look at the same thing for another number. So we'll use 4 maybe, and let's see how it works. So num4 had the label 9 in it, right? So inside this, let's see what our pixels look like now. So if you observe a little carefully, you'll see the number 9 that is being made up by all the pixels that are not 0. So you can see the shape of 9 over here, right? Now similarly, let me just do another number for you. So let's try 3. So 3 had the label 1 in it. So just confirming, 3 had, yep, it had the label 1 in it. So over here, you can see the slant 1, which is expressed as the image. So that was how we basically can inspect our data within an image. So now we're going to be prettifying the matrix or prettify the matrix. So basically we're going to see it in a much better format than we did right now, because I think it might not have made much sense by the pixels that they were. So that way you can kind of see a little more beautifully how it looks. So let me just write down the code again and I'll explain after that. Yeah, that's it. Alright, so here you can see the number 1 being expressed a little more beautifully, and you can see that shape being created in the center from the image. So down again, here you can see it more clearly, right? So using this, you might have got an idea of what the value of a pixel is in a grayscale. So everything ranges from 0 to 255 itself, where 0 is black and 255 is white. And in between all of it would be a grayscale. Alright, moving on to the next part. Let me just add a title for you guys. So the title is Preparing the Input Data. So until now what we did is, we basically explored the data and had a look at it in the matrix format and then prettified the matrix. So in order to now feed our input data into the model data, we need to first prepare the data. So in order to do that, the very first step that we'll be taking is reshaping. So what we'll be achieving from this is, we'll be changing the shape of our original data. So what we'll be doing is, we'll be reshaping the original shape of our data to fit the requirements of the model. So what we'll basically be doing is flattening it. So our model will take the input of a fully connected dense layer, which will be the input layer. So that's why we'll have to flatten it. So basically our 2D image will get converted to a 1D image, or 2-dimensional image will get converted to a 1-dimensional image. So as you can see, I have made use of the reshape function in xtrain.reshape. I'll do the same thing for the x test data as well. So instead of a 28 by 28 image, we'll change it to a flattened image of 784 pixels. So basically what we did is, we unrolled the 28 by 28 pixels into a single dimension. Now we'll run this, and that would complete our step. Alright. So now that we've reshaped our data, the next step will be to change the data type of the inputs. And the reason we're changing the data type is, our neural network works on a float type of data set. So this is not actually required, but it's just the best thing for us to do, to just convert the data type or the data set to float first itself, so that we don't come across any issues or any problems, and it's easier for us as well. So we made use of the .as type of function. So in NumPy, the .as type function is used, but here we converted it to a float type. So now what we've done is, we've converted the value of our pixels from integers to float data type. Moving on, our next step will be normalizing the data set. This is quite an important step as well, so do pay attention. So until now we just changed the shape and made it flat. Then we changed the type to float, and now we'll normalize it. So basically in this step, we shrink our data set and bring it down in the range of 0 to 1 or -1 and +1. That is normalization. Reason being, the computation becomes super simplified if you maintain the numbers between 0 to 1 or -1 and +1. So this is also called scaling, where you're scaling your pixel size, in our case, from 0 to 1 or -1 and +1. So here we'll divide the value of the pixels of every single pixel by 255. So the pixel value would automatically just come down to a range of 0 and 1. So in this way, we will change all the pixel values for xtrain as well as xtest by dividing each pixel by 255. And we've normalized our images now. Alright, so now that all that is done, the next thing or the next step we need to do is to check if all the processes have been implemented. Basically all the steps that we've done have been implemented, as well as check what output has finally been found by us. So let me just write down the code for this. It's a simple code where we just directly print and see what the shape of our data is right now for both our training as well as our test sets. So first let's just do this for x, and once we are done, I'll just run this. Alright, so as you can see over here, we have only one dimensional values. That's because we converted it, or we flattened the image. So it was 28 by 28, now it is 784. So basically what we are left with is we have 60,000 samples, and all these samples are of 784, or basically one dimensional. So now that this is confirmed for us, let's move on. So the next thing I want to check is that from the 60,000, in one particular sample, what is the maximum as well as the minimum value. So in our case, since we have an image, in each or in one particular image, what is the maximum and minimum value of the pixels that are associated with that image. So that is why I just ran this code, and as we can see over here, we have 1 and 1. So I just wrote a code to check the maximum value, and we found the maximum value for xtrain as well as xtest to be 1. Also, if you notice, the pixel has been shown as 1.0. That means our data is of the floating type as well. After which we had converted the data value, so we changed it, and we saw, and we are seeing that it's now in 1 only. So 0 to 1 is the range. So basically all our steps of pre-processing, that is normalization, then reshaping the data, and everything else that we did, they're all applied to our data now. So that was our input data, but now we haven't changed our labels. So we need to prepare our labels as well. So in order to do that, we'll now have a look at how we can pre-process our labels. So pre-processing the labels, unlike the data, doesn't have as many steps as you saw. So let's get into this one and see. The first thing to notice is that our labels are in a single digit integer format. So we'll need to convert this either to a one hot or to a categorical format. So let's have a look at how this works. So the first thing I did is I declared a variable called num_classes, whose value I assigned as 10. And that is because we have 10 classes, right? Then we make use of the toCategorical function, and inside which we will define the number of classes. So with the help of the toCategorical function, our data will get converted. Alright, so you'll get this much better once we see the output. So just be a little patient and let's see how it works. So as you can see, I'm doing this for both ytrain as well as ytest. So that way both the labels or both the types are being processed. Alright, so before I just run this, let me just show you what the labels look like actually. I realized I didn't show that to you. So as you can see over here, the label is a single digit integer, which is the number 5 in the case of 0. So let me just change these values and show you how the labels keep changing. So that was just the general example of what the labels currently look like. So now let's just run this code and see. So right now we are converting this single digit integer to a categorical format by making use of the toCategorical function. So now let's run this. Let me just add a comment before we do. Alright, so the comment will be processing the label. Yep. Or in fact, let me just call it processing step. Yeah, that'll be much better. Alright, so let's just run this. Alright, so now let's have a look at what our labels are like. So y_train and then 0. So after using toCategorical, this is the kind of type that we're seeing now, or result basically. So as you can see, this has now been converted into a NumPy array type, in which the 0, 1, 2, 5th position, yeah, the 5th digit is 1, and that represents the label. So let's see for 2. In this, the 4th position, that represents 4. So basically the point I'm trying to make here is the one that's active will be represented as 1 and the inactive one will be represented as 0. And this is also called as one-hot encoding. This is quite a common step and this is very heavily used as well. Alright, so that was processing. Let's also have a look at the shape of the data now. Sorry, I mean the label. So we'll have a look at what the shape is for the Y training label as well as the Y test labels. So here we have the shape. Alright, here we are seeing a 60,000 by 10 and 10,000 by 10. So this is the kind of shape we are getting right now. So this was for the labels. So basically our labels are now 10,000 by 10 and 60,000 by 10. So that was everything in regards to processing or pre-processing the data as well as pre-processing the labels. So that's it for now. Do make sure to practice the same thing. See you in the next lecture. Thank you.